At first glance, it looks like ordinary steel. But this plate is different. It may one day protect a warship, an armored vehicle, or a crew in the field. Even one sample from the furnace goes through repeated inspection and analysis. Today, cameras and AI also help check the surface. By the time the final plate comes out, you understand why the process is so strict. To make heavy military-grade steel plate, the first major step is smelting. Here, scrap metal arrives at the factory every day. Because of the remote location, local raw ore is not always easy to supply. So old metal parts, industrial offcuts, and scrap are recycled. First, electromagnetic cranes load the scrap into a large bucket. Then it moves by rail toward the electric furnace. This furnace may not look dramatic, but it can hold up to 200 tons. It may not be the largest in the world, but its melting efficiency is impressive. Inside are 3 graphite electrodes, built for extreme heat and capable of very high temperatures. These electrodes are made from processed petroleum coke. The material is calcined, blended, and pressed into shape. Then it is graphitized to conduct power. When the electric arc furnace releases energy, an arc forms between the electrodes. That arc melts the steel charge. Graphite is not as conductive as copper, and the electrodes slowly wear down during use. Next, the ladle moves to the furnace outlet. Typically, this vessel can carry 170 tons of molten metal. That is about 340,000 pounds of raw material. For steel of this grade, the molten metal must be controlled with precision. At around 1,600 degrees Celsius, it churns like a volcano. At this stage, alloying elements are added to give the steel its required properties. That is why workers take samples during the refining process. There's very little room for guesswork here. The standard is strict, so the first batch is checked carefully and tested more than once. This is where the sampling process begins. First, a power saw cuts through the solidified steel sample. This exposes the internal structure of the metal. Then a CNC system moves the sample onto another machine. The goal is to create a cleaner cross-section. Traditional testing includes chemical analysis,
spectroscopy,
and other microscopic examination methods. One test alone cannot confirm the full quality of the material. That is why several methods are combined, only when every requirement is met. Can the steel move on to casting? Whether it becomes plate, bar, or structural steel, the next stage is continuous casting. The process works like shaping a long sheet. Molten steel flows into a controlled mold. Rollers then pull the forming slab forward, while the sides are guided and trimmed. The fresh steel can even be cut while still hot. These steel plates have many military uses. Tank hulls, warship plating, armored vehicle panels, and other heavy-duty equipment may depend on materials like this. Compared with ordinary industrial steel, this process leaves far less room for error. Every flaw matters. Next, a crane places the slab on rollers. Then it is moved to the next workshop. Safety is always a priority. This is a remote-controlled transport vehicle. From a distance, it looks like a train. In many ways, it works like one. It is a specialized carrier. Its advantage is environmental isolation. Rain, snow, or hail will not stop the production flow. In the second workshop, the massive slab must first be divided. CNC positioning helps keep the cut accurate. This reduces variation before the next stage begins. Then it enters the rotary table, ready for controlled reheating. Temperature here directly affects the rolling process. That is why the factory keeps this stage tightly controlled. Simply put, the heating must be even, and after the furnace, the temperature must stay within the limit. For this kind of plate, consistency is critical. This line has high-pressure water. It is used for a special cleaning step. removing the surface oxidation layer. After that, the slab reaches the 4-stand rolling mill. This machine reduces the plate thickness. The rolling system uses massive rollers under heavy pressure. Each pass makes the steel a little thinner. With 4 rolling stands, the plate moves back and forth through the line. But notice this, everything on this line is monitored by trained operators. On the screen nearby, operators can track the rolling condition. In the past, this work relied heavily on eyesight. Today, AI-assisted inspection helps. If cracks, uneven rolling, or defects appear, the system can trigger an alarm. That helps reduce waste and prevent failure. Beside the conveyor, there is a clock-like measuring device. Whenever the steel plate moves, the device rolls along with it. By this point, the plate has changed greatly. Its shape and surface now look completely different. Next, a continuous water rinse cools and cleans the surface. Timing is important here. As the plate moves toward the exit of the line, it has now cooled down. The red glow is gone, and the temperature has dropped. With proper protection, workers can now handle it much more safely. Now the plate moves to visual inspection. The white chalk marks you see here record the batch number and production quantity. A long ruler is used to check the width. A mirror can also be used to inspect the underside of the plate. Any pit mark or rolling defect is recorded one by one. The work may look repetitive, but this is how hidden problems are caught. Is this already the final military standard? Not yet. So far, they have only checked the material quality. Now they must prove how the steel performs. That includes impact resistance, tensile strength, corrosion resistance, and weld strength. In total, there are several rounds of testing. Because some details are sensitive, only the tensile test is shown here. Metal testing is handled by material specialists. Through this test, they can measure the metal's elastic limit, yield strength, elongation, and overall toughness. For example, when an armored plate is struck, it should deform and absorb energy instead of cracking apart and creating more danger.